In this section, we're going to take derivatives using differentiation rules. First problem is y is equal to 4 minus x cubed minus x to the negative 1. So y prime, the derivative of 4 is 0. Derivative of x cubed is 3x squared. And then the derivative of x to the minus 1 is negative x to the negative 2. So I get y prime is going to be minus 3x squared plus x to the negative 2. And by the same principle, y double prime is going to be minus 6x squared or negative 6x squared. And then I'm going to get minus 2x to the negative 3. In this problem, we're going to use the quotient rule. So we're going to get y prime is the bottom, 3x plus 14, times the derivative to the top, which is 2x, which is 2, minus the top, which is 3x, which is 2x, times the derivative to the bottom, which is 3, all over the bottom squared, which is 3x plus 14 quantity squared. So now we get y prime is 3x times 2 is 6x, and then 14 times 2 is 28, minus, I'm going to get 2x times 3 is going to be 6x, and I'm going to have negative minus a negative, which is going to give me a plus 21. And that is all over 3x plus 14 quantity squared. So now I get y prime turns out to be 28 plus 21, which is going to be 49, because this 6x and this negative 6x are going to add to 0. And that is over 3x plus 14 squared. So there's our derivative. So now we need to find the second derivative. In order to find the second derivative, I could use a product rule in the denominator, which could actually be somewhat difficult. So I think I'm just going to multiply the denominator out for this problem because it's only a square. So y prime is 49 divided by 3x squared is going to give me 9x squared. Then I'm going to get 2 times 3 times 14, 84x, and 14 squared, 196. So this is a new form of y prime. So now let's do the quotient rule to find y double prime. So it's going to be the bottom, 9x squared plus 84x plus 196 times the derivative of the top. Oh, well, that's 0, minus the top, which is 49, times the derivative of the bottom, which is 18x squared, 18x plus 84, all over the bottom squared. So now we're going to get y double prime is going to be negative 49 times 18x plus 84 divided by 9x squared plus 84x plus 196. This could be simplified further, but I'm concerned about you understanding the mechanics of the problem. And I think we did that. So in this next problem, y is going to equal, I'm going to rewrite it as x to the 1/2 plus x times 5 minus x. So we're going to use the product rule. So we're going to get y prime is the first times the derivative of the second, which is minus 1, plus the second times the derivative of the first. Okay, so that's our derivative. So y prime is a negative x to the minus 1/2 minus x. And now we're going to take 5 minus x times the first term. And that's going to give us 5 times 1/2. So I'm going to get 5 times 5/2 x to the minus 1/2. And then I'm going to get minus 1/2 x to the positive 1/2. And next, I'm going to take 5 minus x, and I'm going to multiply it by this second term. So now I'm just going to get plus 5 minus x. So I get y prime. I have my x terms look like minus x and minus x. So that's going to give me minus 2x. My x to the 1/2 terms are going to give me minus 1/2 x to the positive 1/2. That's these terms here. That only one term. And then my next terms are x to the negative 1/2. I have 5/2 x to the minus 1/2 and minus 1 x to the minus 1/2. So that's going to give me 3/2 x to the minus 1/2. And then I still have left a constant, which is 5. So there is my first derivative. So let's do our second derivative, which is much easier. It's going to be negative 2 minus 1/4 x to the minus 1/2. Then it's going to be minus 3/4 x to the minus 3/2. And the derivative of 5 is a constant. Let's double check. And that looks correct. Now here we have a combination product rule and quotient rule. So to make our lives simple, we're going to multiply the numerator out first. So we're going to get that y, we multiply the numerator, we're going to get 2x squared. We're going to have 6x minus 5x is going to give us plus x. And then we're going to get minus 15. And we're going to divide that by 2x to the 1/2 power minus 1. So therefore, y prime is the bottom times the derivative of the top, which looks like 4x plus 1, minus the top, which is 2x squared plus x minus 15, times the derivative of the bottom, which is x to the minus 1/2, because minus 1 goes to 0, all over the denominator squared. So we get y prime. We're going to take this first term and multiply it by 4x. So we're going to get 8x to the 3/2 power. And then we're going to get minus 4x. And then we're going to take this term and multiply it by 1. So that's going to give us plus 2x to the 1/2 minus 1. And then we're going to subtract off 2x squared times x to the 1/2 is going to give us 2x to the 3/2 power. And then we're going to get minus x to the 1/2 power. And then we're going to get minus a negative is going to give us plus 15x to the minus 1/2 power. And this is all over two x to the 1/2 power minus 1. Let's double check our work. Okay. So we get y prime. The highest power of x is just x, so I'm going to get minus 4x. Then my next is my power of x to the 3/2. I have 8 and negative 2 of them. So that's going to give me 6x to the 3/2 power. Oh, that's the highest power of x, is the 3/2. And then we're going to do x to the 1/2. So I have 2 of them and minus 1 of them. So that's going to give me 1x to the 1/2. And then x to the negative 1/2, we only have one of those. And any constants that we still have left, and that would be minus 1. Divided by 2x to the 1/2 minus 1 quantity squared. So let's just double check. We have 8x to the 3/2 and negative 2x to the 3/2 gives us 6x to the 3/2. We have minus 4x all by itself. We have 2x to the 1/2 minus x to the 1/2 gives us just one of them. We have only one x to the okay, there is a mistake. Let's find it. There should be a 15 in here. Okay, much better. -1. Okay. Last problem. Find equations for the horizontal tangents. Okay, so let's think about this. If we have a horizontal tangent, so anytime we have a horizontal tangent that looks like this, or it looks like this, and with the horizontal tangent, that means the derivative is 0, or the slope. So we want to take the derivative, y prime. The y is equal to x cubed minus 3x minus 2. So we want to take the derivative, y prime is 3x squared minus 3. So that's the derivative, and we want to set that thing equal to 0. So that gives us 3 times x squared minus 1 is equal to 0, or 3 times x minus 1 times x plus 1 is equal to 0. So x is equal to plus and minus 1. So we have two places where our derivative is actually equal to 0 in this particular function. So the first is when x is equal to, when x is equal to -1. So if x is equal to -1, what is y? Well, y is going to be -1 minus a plus 3 minus 2, so equals 0. So we have the line y equals 0 is a horizontal tangent at x equal to -1. And let's look at x equals 1. So x equals 1, we're going to get y is equal to 1 minus 3 minus 2, which is -4. So therefore the line y equal to -4 is a horizontal tangent at x equal to +1. So those are the equations of the horizontal tangents to this curve. Last problem is to find the tangent to Newton's serpentine at the origin. So Newton's serpentine is y is equal to 4x divided by x squared plus 1. So let's take its derivative to find the slope of the tangent line. So that's going to be the bottom, which is x squared plus 1, times the derivative to the top, which is 4, minus the top, which is 4x, times the derivative of the bottom, which is 2x, divided by the bottom squared. So now I get y prime, 4x squared plus 4 minus 8x squared all over x squared plus 1 quantity squared. So that simplifies to y prime is equal to minus 4x squared plus 4 divided by x squared plus 1 quantity squared. So we want to find the tangent line. So therefore, we end up getting that slope m is going to be f prime, and this is at the origin. So that's going to give me 4 over 1, which is just 4. So the slope is 4. And then what is the y value at the origin? Well, the y value at the origin is 0. So f of 0 is 0. So I have the point, so the slope m is equal to 4, and my point is x is equal to 0 and y is equal to 4. So I end up with y that's incorrect. It goes to the point 0, 0. So I just get y is equal to 4x. At the origin, we have the point 0, 0. We take the derivative is 4. So we have slope m equals 4, and then we have the point 0, 0. So the point slope form of the line gives us exactly what we have.